So I think that we're recording now just for the benefit of anyone who can join us tonight. And first of all, excellent work. I'm very pleased to see the great work that's going in. Uh, I'm very appreciative of your good work. And for today, what we had planned was to have a look of the lab, and that's going to be the first lab, which is all about the uh, scientific method and proper hand washing. So let me just share my screen. And while we're getting started with sharing the screen, if I could ask you to do me a favor and again, type your name into the chat so I can take the attendance through there. Excellent. I really appreciate it. And I think that I prepared a little bit of a small PowerPoint just to go through with this together with you guys. Couple of words in general about the labs and these sessions that we have where we review the material for the labs. Typically, you should be able to get most of the answers from these sessions if you attend. So there shouldn't be too many surprises or unexpected questions afterwards. But of course, I'm always here to help you, so never hesitate to either shout out here during a session or drop me a message. The Blackboard is really the quickest way to hear back. I do check, of course, the emails and answer to those. And just like you guys, the first week is usually the most hectic one. So I'm slowly getting on top of the normal things. But this week on this lab that we're starting with, our course, we're looking at proper hand washing. And this is kind of continuation of what we had a look of when we talked about the proper lab practices and lab safety aspects. So during that first lab, I think I labeled it as lab 0, we made sure that you're all comfortable, all knowledgeable of all the things about how to work safely in a lab. And this really ties into that quite nicely because CDC, that's been largely in media recently, they have this nice quote that I've digged out from their website that really one of the best ways to remove any germs and avoiding getting sick and prevent spread of these germs is really to wash your hands. So proper hand washing becomes so important. And if we look at it in terms of the history, that is when the medicine really moved ahead and we made leaps and bounds of advances. When we realized that being clean, having sterile tools, having sterile environment where we treat patients and do procedures makes all the difference. So really proper hand washing is important. And proper hand washing is a nice little exercise that we do in a class when we are face to face. Of course, now we're in an online setting. So on this setting, we don't get to do it quite ourselves, but I've actually done the exercise for you. And we're going to work together to assume what could happen and why that could be the case. What we'll have a look of is washing the hands. So in this experiment, we're just using water and soap, nothing fancy, nothing extra. And we have 3 conditions. So we are going to have a look of, and I'm just trying to get my highlighter here. We're having a look of situation where we do none of the hand washing. So in this case, we just have a look, how much germs would we find on one's hand if we don't wash those hands just in normal day-to-day living. The second condition that we're going to have a look of is that what if we wash hands, but we really don't do a great job on that? For example, we could just swing our hands quickly under the water and that's it. And the final condition, of course, would be to do that properly. And the procedure for proper hand washing is usually available on the wall on top of the sinks in any medical site. And I really encourage you to take the time that it takes to wash hands properly. So it does take time. You want to go through all the surfaces, yet you also want to go underneath the nails. So all parts of the hand do get covered with soap, and then you wash the soap off as well. As a little tip that I'm gonna give to you guys, remember when you've done all that work of washing your hands, you don't want to get them dirty. So I at least do it, and I know that quite a few other people do it. Turn off the tap always with a piece of nap paper or whatever you've used to dry your hands. You don't want to put your nice clean hands right to that tap that's probably gotten dirty when people turn it on with the dirty hands or unclean hands. So that's something to keep on mind. Last time we talked about the scientific method as part of our class. And we saw that there were quite a few steps. And I think on this particular diagram that we have here, I've actually added one more step that I didn't have in that initial version that we had, which would be the discussion. So of course, before we jump into conclusions, we might include a little discussion. Sometimes the discussion is included in the conclusion section. But just as a quick recap, some of the most important steps, and I'm not going to go through all of these, but some of the most important steps that you need to have in good scientific process, conducting an experiment following the scientific method, is that you have some sort of a question that you're looking. We really want to have something that we're wanting to find out. And often, really verbalizing that question can be quite hard. It might not be super easy. It might take a little effort, but doing it well is definitely worth it. Nothing's as disappointing as you have a nice study that you've done, experiment, you've got nice data, but you realize that you asked the question in a little wrong way. So the data doesn't quite answer what you actually wanted to find out. So it's worth of spending time on that. And the second thing that I wanted to highlight here is, of course, the hypothesis. And we're going to talk about hypothesis, I think, in the next slide a little more. But remember that hypothesis was this tentative explanation that we have for whatever we're wanting to study. So we come up with a educated guess, if you wish, to predict why would we see and what would we see. Of course, we do want to conduct the experiment, so we want to collect the data. The data might be in a lab experiment, or as we saw in the case of Jane Goodall, it can be observational data that we follow. The experiment in that case would be to be there with the apes and study them, observe them, collect the data in that way. So not all studies are lab-based, but some type of an experiment is part of all of them. And we do want to get some results. And remember that results section is really nothing else. If you're reporting your study, it's really nothing else than the numeric summary of what you found out. You don't really go yet into explaining why that might be the case. Why that might be the case is reserved for the discussion part. In discussion part, you now look at the numeric information that you collected and you try to start to make sense of it. So we save that to that step. And the final step that I wanted to highlight here was to come up with some sort of a conclusion. So all of these are important steps. Of course, we would love to do every single step that we see here. And often we do it, we might not think about it as much, but if nothing else, it is these steps that I've highlighted here, these 6 steps that you should have in your experiment when we're conducting them in science labs as part of this course. So you want to make sure that you have the question, you have the hypothesis, you conduct the experiment, you get results, you have some sort of a discussion about it, and you come up with the conclusion. So at this point, what I would like to do with you guys is to just really quickly review that what makes a good hypothesis. So we talked about hypothesis being kind of a educated guess or early explanation. So at this point, we don't yet know what we're going to find out. But of course, we must have some knowledge about the topic before we actually start studying it. Otherwise, we would just pick up topics at random, and it really wouldn't be based on any previous knowledge, any previous observations, anything like that. So we have this supposed, or we might propose an explanation for what we might see in the experiment. This explanation is based on limited experience, so we will not know for sure that that's gonna be the correct explanation, but it is an explanation nonetheless. So sometimes it's better to have something, even if it's not perfect, than not have anything. So it really serves as this starting point for further investigation. So we acknowledge that it might not be the real reason behind what we're wanting to find, but based on our early knowledge at the starting point of the study, that is the best explanation that we have. And if I can give you any tip or one tip for really getting those good points on this lab, I am going to be asking you to formulate an explanation about what do you think will happen when we don't wash hands at all, we wash hands poorly, or we do a really good job of washing hands. So those would be the three conditions that I mentioned here earlier on. So we are going to need to now formulate, and we're going to do this together tonight, but that's going to be a question in your actual lab activity. So we're going to have to come up with some sort of an explanation that what, or some sort of a hypothesis that what could be happening in these three different conditions. And because we have three different conditions, of course, our hypothesis might be a little broader than just a simple statement. And what I want to do, I want to give you a good tip to really excel in formulating a good hypothesis. A good hypothesis uses these two words that we see on the screen now. It uses the term if, and then it uses the word then. So we're saying that we're expecting to see this if we do that. So let's think together, and I'm going to ask you to share ideas how you would tackle formulating the hypothesis, because once you have a good hypothesis, you can just use that in your actual lab exercise. But what would be a good hypothesis for an experiment where we are comparing three conditions: not washing hands poorly, and washing hands in a following the proper procedure? And then let's formulate that by using those words if and then. So feel free, if you already have an idea, to shoot something to the chat. If you don't have an idea yet, we will work on it together, and we will take some ideas that we're seeing and try to kind of move further with those and see what could we come up with. So how about we start with an idea? If you do not wash your hands, well, what do we expect to see? What do we expect to see? If you don't wash your hands, then you can spread germs to yourself and others. That is perfect. Excellent job there. That's a really good idea. And how we are having a look of these germs in this lab is that we actually take growth plate where we have material that the bacteria, germs, all sorts of things grow really nicely, and we take the sample of that individual's hand and have a look how much of germs will grow on that plate. So if you don't wash your hands, then we probably expect to see a lot of those germs in that growth plate. Wouldn't that make a good sense? That would be a good hypothesis to start with. But that's only one part of the hypothesis for this lab, because then we're also going to talk about washing hands poorly and washing hands properly. Well, if you don't wash your hands, then you can spread germs to yourself and others. That's our first part. What else could we say? And feel free to shoot on the chat. What else could we say? If you follow proper hand washing techniques, then what are we going to see in comparison to poor hand washing? If subject properly washes their hands, then their hands should be clean. That's excellent. Great job there. So if the subject properly washes their hands, then their hands should be cleaner than they should be if you don't wash your hands properly, or you don't wash your hands at all. Perfect. How you are going to choose to phrase that statement is up to you, but I think that we have all of the elements and all the idea that we want to have for a good hypothesis. So excellent job there. And of course, as always, I will give you extra credit for having shared some of the ideas there on the chat. So know that I really do appreciate it. Well, now we have a great hypothesis. And before I actually jump too far, does anyone have any questions about how to tackle this part of formulating a hypothesis? Do we feel good about it? Just remember to try to include the word if and then, and in that case, you already have a really good hypothesis. And I think that we've seen two great examples. You might do some sort of a mashup of those two. Well, I don't see any questions coming in, but as always, if you do have questions at any point, you can just turn your mic on and give me a shout out, or you can type to the chat. I'll try to monitor the chat, but I'm gonna move ahead and let's have a look what happened when we did all this. So you should be able to see on the screen 3 pictures. What you see on those pictures are round circles. That round circle is the growth plate. So we have poured on this small disc-like container a mixture of various things that germs love to live in. So there's nutrients for them, there's moisture. We talked earlier on how all of the living things were made of water. So we have both water, what the germs need, and we have food for them. In addition to that, once we had collected the sample on each of these 3 dishes, we put these dishes into a warm environment so that it was really nice and cozy for these germs to live on this growth plate and multiply and make it to their home. So over time, we see them growing more and more when we give them the ideal conditions, both in terms of the humidity, nutrients, and then the temperature. And the ideal temperature is a little warmer than normal room temperature. So what we ended up seeing is that all of those 3 plates looked very different from each other. On the first picture that you can see, and I'm trying to take again marker that you can see here. So that's the first one. We're seeing that when we did no hand washing at all and collected the sample, so we could have collected the sample by either wiping the hands and then spreading it on that plate, or if the plate was big enough, we just told the person to put their hand to that plate and kind of touch the surface of the growth media and then take it away. What we see is that there's a bunch of these white dots And each of these dots is one colony. And what it is, it can be various different kinds of bacteria or other germs. We haven't gone as far on this as actually identifying what germs they are. We are going to do so later on your studies on BIO181, which is the microbiology course. You'll actually get to separate the germs from these growth plates and find out which germ is which kind. And we can actually also separate the germs by using different kinds of nutrients. Some germs prefer one type of food, others prefer other kinds. So we get to the nitty-gritty later on your studies. But at this point, all we want to do is say that yes, something grew on that plate. And quite a lot of stuff grew. If we look at these colonies, and again, I'm going to try to take a laser pointer against of the red color. It doesn't show that well, but do your best. What we'll see also that these colonies, these dots, are rather large. So there's a lot of stuff growing in each of these dots. So that's the observation that we're going to end up doing for no hand washing. So definitely there were germs on that hand, and definitely they were significant amounts. Let's look at the second picture, and that second picture is going to be the picture bang on the middle of the screen. This is the condition of poor hand washing. So now we wash the hands, but the hand washing wasn't quite done properly. Well, we're probably not going to be surprised to see that there is going to be some germs on those hands. What we'll see is that those colonies are a little smaller in size, but there's more of them. So I don't know about you, but I'm finding that a little surprising. So I thought that, well, certainly not washing hands at all would be the worst thing. And now what we're seeing that poor hand washing, it seems to be almost as bad, if not even a little bit worse in terms of the number of colonies. Of course, the size of colonies is not quite as big, but there's a lot going on. So that's a little unexpected, but that's our finding, that's our result. And that happens in science a lot, that we end up expecting something, but then when we're working on an experiment, we end up finding that it quite doesn't go that way. And we talked about discovery of certain medications. I used one example during our class earlier this week. And we could also, there's a lot of medications. We could pull up many other examples, but let's just stick with that one. So sometimes we find things that we don't expect. Let's look at the last picture, the right-hand picture on this screen, and what we're finding there. So I'm labeling that picture as number 3, the condition 3, which was the proper hand washing. And what we're finding on that plate is that it's really clean. There are few occasional germs here and there, but that's really not a lot of germs at all. And that amount of germs could have gotten to that plate just while we were doing the experiment. The hands might have been perfectly clean, but from the air, something landed, or someone was talking next to the experiment subject while we were working on that, and something flew from their mouth, or someone was scratching their head, maybe something fell out, or maybe even just when you washed your hands, you ended up turning off the water tab and you got some germs from that. So there's a tiny amount of germs on that plate, but I think this one aligns with what I would expect, that if we wash our hands well, we have the least amount of germs on that plate. Do we all agree what we have seen here together? Does anyone else strongly disagree or see something different? It's okay. Sometimes we perceive things also differently. So it's okay. You can shout out if that's the case. Well, let's have a look, because we are scientists. We don't want to just provide a picture. We also want to do some sort of a quantification. So we talked about quantitative science, where we try to assign numbers rather than just doing descriptive science, which is what we just did earlier on when we looked at these pictures where we described what we did. Let's make it a little bit more quantifiable. So we have here, and I've done this for you because I have a lot of time in my hands, apparently. I have counted how many colonies did we see on each of these. So on this plate, where we did no hand washing at all, I counted 75 colonies. So each of those colonies is one of those small dots. The largest colony was 6 millimeters in diameter. So something like this size. And we always use the metric system in science. That's a common system that's used across the world. And we'll talk about why we prefer to use metric system in one of our future labs. And then I also went and did what I told you earlier on that we can do with different processes to isolate different kinds of bacteria from these colonies. And what I ended up finding was that there were 4 different kinds of bacteria on this no hand washing plate. So when we don't do any hand washing, we find a good number of colonies. The colonies are much larger than in any other condition, and we find more bacteria as well. And the last measure that you see here is that based on these numbers, how would I rate it? I decided to rate that if I added 3 pluses, that was the most amount of bacterial growth. And if I added 1 plus, that was the least amount. And 2 pluses was something in between. So now let's have a look of the second plate that we have, which is the poor hand washing. This was the surprise part, at least for me. And you might be like, no, I wasn't surprised at all. And that's fine. That's a good observation. You can tell that no, you were expecting. But what we'll end up noticing is that there were way more colonies than in the first condition on this poor hand washing condition. So 256 colonies is what I counted from that plate. However, if we look at the diameter of the largest colony, I think that it was here or this one, versus on this first one, it was this large one here. The diameter of the largest colony is much smaller than what we saw before. And we only found 3 different types of bacteria. So we did get rid of some of the bacteria, and we got rid of the colonies were much smaller, but we did have more colonies. So I rated this overall as kind of a medium amount of bacterial growth. And the final plate that we see here was the proper hand washing, which is the last of these rows that we see on this table. And from there, I actually counted 11 different colonies. Some of the colonies are really tiny, so I don't know if the picture does quite the justice for that. The diameter of the largest colony, which I think was here, was 3 millimeters. So it was a little bigger than on the poor hand washing condition, but way, way, way smaller than on the no hand washing condition. And like we saw, there was least amount of colonies out of all, and there were only 2 different bacterial types that I could separate from this dish. So overall, there was very little bacterial growth on this condition. So this shows you how we go from descriptive to actually quantitative data. So here we quantified what we saw earlier on those plates. So that's what you and I have now been able to get out of these labs so far. Well, if we look, sometimes we end up finding unexpected results. And like I said, that's not uncommon in science. That happens actually quite a lot. Oh, I didn't mean to do that. Let's see if I can wipe that off just really quickly. That looks better. So the unexpected finding that I found in this case, or we found when we worked on this, was that the number of colonies was greatest in the poor hand washing Petri dish. So we did not expect that, but that's what we found. Well, what I'm going to ask you to do, and we're not going to do that together now on this session, but one of the questions on this week's lab is that I'm asking you to come up with at least one explanation why this could be the case. And there's many explanations, and your explanation is just as good as mine or anyone else's. So as long as there is a solid logic behind it, that explanation is absolutely fine. We might never find out why the number of colonies was the greatest in the poor hand washing Petri dish. If you are totally stuck, some of the things that you could consider is that, for example, do we think that having the water somehow make the bacteria to spread more? Or do we think that by giving that water, because it wasn't good hand washing, it actually worked as a nutrition and something that the bacteria could benefit from? Or do we think that there was some sort of a contamination while we were conducting this experiment? There's many reasons, and I really encourage you to come up with your own explanation. What could it be? And of course, if you provide me more explanations, you'll find out on this course that I love to give extra credit. So more you give me, more points I can give you on this lab. So don't hesitate to share even few if you think of them. But for full marks, I'm only asking for one explanation. The other thing that I'm asking you is to reflect on this lab. And I try to do that with every lab that we do. I try to get you to think of, did this work out good? Was there anything we could do differently? How could we improve this lab? How could we get better results? One way that's often a good idea is that let's do it more times and then take an average of all those times that we did. But doing something just more times is kind of an easy escape as a reflection and explanation how to improve the lab. I'm looking for something else. Could you come up with another kind of explanation how we could improve this? And again, if you do get stuck, don't hesitate to reach out to me, but there's many reasons I think that how we could make this lab better. We can think of, is your idea of good hand washing same as mine idea of good hand washing? Is if we're doing this with 3 different people, how about if my hands are super dirty and your ones aren't? Would that affect it? Or could there be that the soap that we used was very different? Or could there have been a clean or versus dirty environment where we did this experiment? So there's many reasons. And again, I'm looking for you to come up with your own idea how we could improve this. What could we do? I've given you a few starters if you get totally stuck. And again, I'm only asking for one, but if you do come up with more, I'll give extra credit on this assignment. The last thing that I'm yet to share is that there is an actual extra credit question on this lab. I have 4th Petri dish that I did, and I didn't show you what it looked like yet. You're gonna see what it looked like when you actually work through this lab on the blackboard. But I did a 4th experiment where we had a look of how would it look if we wash our hands properly, but we don't dry those hands at all. Would it be more or less than a good hand washing? Would it be more or less than poor hand washing or no hand washing at all? So that's something that you'll see at the very end of this lab when you work on it on your blackboard. And if you tackle that and analyze what you see on that, that counts as extra credit. So there's no reason why you couldn't get more than 100% on this lab. And all in all, that is really the lab that I'm asking you to do this week. I encourage you to take the time to look at the pictures and read the text. I know that it would be way more fun if we all could be doing it together in a lab, but because of the global pandemic, at the moment, we're just gonna have to make do the best we can in a remote setting. And I promise you that I did those hand washing things properly, and I had good subjects helping me on that, and so on. So those are real pictures of what you would expect to see when if you did this lab yourself in a class. So you're learning all the same stuff even though we're not in person in a classroom. So really, without further ado, that is all I am asking you to do on this week's lab. And this is a good time to tackle. If you have any questions, don't hesitate to let me know. Or if you have any questions about anything else that we've covered, or if you're worried about anything, or if everything's going great and you want to tell me that, I am going to be around here on our meeting room, so you can have a chat with me. But if you don't have any questions, if you feel super happy, we can wrap up earlier today, and you can use the remaining of the time to go actually and get that lab knocked out of the way. So that's all I have for tonight. But again, if you have any questions, feel free to ask. Otherwise, enjoy your evening, and we'll see next week when we're gonna move on to new material. Thank you. I really appreciate you joining me. Thanks. Have a good night. Excellent. Try to get that lab done. It's always good to get them out of the way. And if you want, you can always retry it. Thank you. Enjoy your evening. I'm going to turn off the recording now. So again, if you have any questions, you can still ask, but otherwise, have a good night. Okay, for the fourth bacteria sample, where it was properly washing your hands but not drying, there is a white spot, and you wanted to know what was that the glare or actual bacteria? That's a really good question. I do think that it is actual bacteria, but you could, for example, even if you write that observation on your answer, that you're not sure, you're seeing something, but you would need to investigate it more further, that would be perfect answer to that. I do think that it was a real bacteria, but that's sort of attention to the detail that I'm looking for. I think that you have an answer word of extra credit there. I hope that that helped. Yeah, you can say, absolutely. You can just say that, well, we would actually need to investigate that a little further. And then you can say why. And that would be a really good answer. I would be very impressed with that. Excellent. Thank you. Thank you for a good question. Have a good night. If you're wondering why I'm sticking around, I'm just taking the attendance and making a couple of notes. But really, I have nothing other new information. So you're free to go and enjoy your evening.